Alright, so in this video, I will show you how to solve all problems in the practice test. Uh, First problem, find integral 5x squared plus x to 6 dx. So here you can see that we have power functions already, right? So basically, to solve this integral, we need to apply the power rule, which states x to p dx equal to x to p plus 1 more p plus 1 plus c. And this formula works for p not equal to 1. So I write this equal to 5 over 3 x cubed. Here we have the power 1, so I increase the power by 1 and divide by 2, and here I have 6x plus c. And that is pretty simple, right? The second integral is integral of 4 secant squared of x minus 5 sine x dx. So here we have secant square and we have sine of x. For sine of x, probably you can guess the integral or antiderivative of sine of x is negative cosine, right? So if I will break this integral into two integrals, I have 4 times secant square of x dx, and then minus 5 integral of sine of x dx. And integral of sine of x is just negative cosine of x plus c, negative with negative 5, minus 5, let's say that. Minus 5. And then, what is antiderivative of cosecant square? So that is negative 4 times cotangent of x. Because cotangent of x derivative is cosecant square, negative cosecant square. So that's why when we take antiderivative, there should be negative 4 times cotangent. So overall, I have this answer. The next integral is integral of 3e to x minus 2 over x dx. So you have seen these integrals in the quiz. You have 3ex over 2 over x. So here I can break it into this integral into 2. So I have ex dx and then minus 2 dx over x. So if you pay attention, this is some kind of power function, but the power is equal to negative 1. So we cannot apply the previous formula for this function. But that is very typical. Antiderivative of e to x is just dx. And then since we have dx over x, the antiderivative of this function is ln of x. That is your answer. So basically in the first problem, you would have 3 integrals, right? And here you see sine or cosine, tangent, cotangent, cosecant, power functions, exponential, and logarithmic functions. Let's move to the second question in this practice test. So in the second question, they ask you to recover the function by solving some differential equation with some initial conditions. Let's say you have the second derivative is equal to 2 cosine of x, and the initial condition f derivative of 0 is 5. The second initial condition is f of 0 equal to negative 6. So don't forget, in this case you have second derivative. Since this is second derivative, we would need 2 initial conditions, to determine the function. In order to solve this problem, we have to take integral twice. I mean, first, if you want to see f, right? If we are given f derivative and you want to recover f, you have to apply antiderivative to f of x dx. So that means we take derivative 1 time. But in this case, we are given second derivative. So that means we have to apply antiderivative one time in order to get the first derivative, and then apply antiderivative one more time to get the current one. Okay, so let's do that. From this scheme, I would say f derivative of x is equal to integral of 2 cosine of x dx. Right? That's how we apply this step. Recover the first derivative by using the second derivative. And antiderivative of cosine is just sine, right? So I have 2 times sine of x. Don't forget the constant. Okay, now we have to use this initial condition to find the constant c. Because derivative of s0 is 5, so I just plug 0 into this sine and I set it equal to 5, right? From here I get 2 sine of 0 plus c equal to 5, and then c is equal to 5. You see? That's not that bad, right? So since c equal to 5, the derivative is 2 sine of x plus 5. From here I can write the derivative of x is 2 sine of x plus 5. And now we already have the first derivative, and we want to recover the current function. Let's apply antiderivative to the first derivative. So I have the following one. The function is equal to integral of 2 sine of x plus 5 dx. Right? Integral of the derivative. So that is equal to negative 2 cosine of x plus 5 of x plus c. Of course, we denote by c as a constant, but c could be different. And now we have to determine c, and we can use the second initial condition, right? So I plug 0 into this function and set it equal to negative 6. I'll get negative 2 cosine of 0 plus 5 times 0 plus c equal to negative 6. Cosine of 0 is 1, right? So I have negative 2 in here. Negative 2 is 0 plus c equal to negative 6. From here I get 6 equal to negative 4. C equal to negative 4. So what does it mean? That means I have to plug negative 4 into this, right, to get the function. And finally, that is what we need. F of x equal to negative cosine, 2 cosine plus 5x minus 4. That is the second problem. The next problem, maybe that's one of the most difficult in this test. Use the Riemann sum. So we had this problem today on the quiz, and most of students failed this question. It's amazing. But again, here we use n equal to 4, right? The function f x is sine of pi x. The interval is 0 and 1, and n is 4. And in this case, I asked you to use the right endpoint, but on the test you would have like just use right or left endpoints, whatever you want. I will write general formula of the Riemann sum first. So the general formula looks like f of xi delta x from 1 to n. Of course, if you pay attention, when we use I goes from 1 to n, which means that we use right endpoints, right? And what if we use left endpoints? We have the following one: I from 0 to n minus 1 f of xi delta x. Right? And all subintervals have the same width. So let's choose whatever you want. And in these formulas, we need to find delta x, we need to find xi, right? And then we plug xi into the function. Okay? So let's find delta x. Since n is equal to 4, delta x is equal to b minus a over 4, which is 1 minus 0 over 4, that is 1/4. 1/4. And then xi is equal to x0 plus I delta x. So don't forget about that. Because each step is delta x. So if we go from x0 to xi, that means we realize I steps, right? And the length is equal to x0 plus I times delta x. Okay. X0 in this case is 0 because we consider interval 0 and 1. So x0 is 0. I delta x 1/4. Overall xi is equal to I over 4. Alright? And now we plot all these xi's in one of these formulas to estimate the definite integral. Okay, let's use right endpoints, right? So for the right endpoint I have, that is delta x. Here I have f of x1 plus f of x2 plus f of x3 plus f of x4. Delta x is 1/4. X1 is 1 over 4. So I have sine of 1 over 4. Pi times 1 over 4. You see that? F of x is sine pi over x. But x is equal to 1/4. So the first term is sine of pi times 1/4. Similarly, we have sine of pi times 2/4 plus sine of pi times 3/4 and then sine of pi times 4 over 4. And now you just use calculator to find each terms and then sum them up, you get the answer. Okay, so the answer you can see this is about square root of 2 plus 1 over 4. So the answer. Please do that yourself and check with my solution. Alright, that is the third question. Let's move to the fourth one. In this problem, we need to solve the area, right? Find the area of the region bounded by the graph of the equation y equal to x minus x squared, x equal to 0, x equal to 1, and y equal to 0. So in this problem, we have to find the area of the region bounded by some curves. And don't forget, because you know when we study this problem, I onward mentioned first we need to understand the graph of the function, because if we have a wrong understanding about the graph, we might have a wrong understanding about the region, and so we have a wrong area. Make sense? Let me remind you about those pictures. Maybe we have something like that, right? And sometimes we have the area like this, but sometimes we might have the following things. Right? For this case, the area is positive because the function is always positive. The graph of that function is above x-axis. In this case, the area when you apply definite integral, the area is negative. We call the negative area. But the actual area is equal to absolute of this. And in this case, if you have 3 x-intercepts in here, right, you have to break integral into 2 integrals. First, you consider integral on this interval. And secondly, you consider integral on this interval. This area is positive. This area is negative. Let's say that here is S1, here is S2. So the actual area should be absolute of S1 plus absolute of X2. So don't forget about that. So that's why first thing we need to do with this problem is to have a brief graph of this function. But this function is, you know, not difficult. This is a parabola, right? This is problem. Let's graph that. So I see the graph of this function intersect with x-axis at 2 points when x equal to 0 and x equal to 1. And since the coefficient here is negative, the function, the parabola is concave, right? Looks like this. And this is 0, this is 1. We can find 0 and 1 because that 0 and 1 are x-intercept. So in order to find it, you just set it equal to 0. And you can see x1 minus x equal to 0. From here, x equal to 0 and x equal to 1. So that's how I found 0 and 1. Okay, so our region is bounded by the graph of this function x equal to 0, x equal to 1, and y equal to 0. So this is y equal to 0. Basically, the region we have is this. And we need to find its area. Okay, so we are in the first case, right? That's perfect. The function is always positive on 0 and 1. So we just need to take definite integral. The area is equal to definite integral from 0 to 1, x minus x squared dx. And that is 1 over 2x squared minus x cubed over 3. You evaluate from 0 and 1. You see? And now you plug 1 into this, you plug 0 into this function, you get the answer. Let's do that. Then here, this is equal 1 over 2, 1 square minus 1 cube over 3 minus 1 over 2, 0 square minus 0 cube over 3. This term is just 0, and this 1 over 2 minus 1 over 3, which is 1 over 6. So the answer is 1 over 6. All right. The last question. Last question. This is what we covered yesterday and today. Evaluate the definite integral x cubed 3x to 4 plus 5 dx. So you see, this function looks complicated, right? Looks complicated, but this okay. So today we study how to determine substitution. If we do a good substitution, we almost finish this problem. So here we have to see the composite function, right? The composite function in this integral is square root 2x4 plus 5. So basically we need to put u equal to 3x4 plus 5. And then after this we have to find differential right away. I'll write du equal to 12 x cubed dx. 12x cubed dx. And now I will check. I'll check my original integral. We put this equal to u. So basically, if we rewrite this, we have square root of u, right? Right? So we still have x cubed and dx. You see? X cubed and dx. How can we express x cubed times dx via u or du? We can find that in here. This is x cubed dx. So I need to solve x cubed dx equal to du over 12. Alright? So basically, this is du over 12. And then let's rewrite the original integral in terms of u. So I have integral of square root of u du over 12. That's it. Let's evaluate this with respect to du. And that is u to 1 over 2, 1 over 12 du, 1 over 12 u, 1 over 2 plus 1, 1 over 2 plus 1. This is the power rule, right? Plus constant. And then you have, this is 3 over 2. But when we divide it, we flip 2 over 3. So I have 2 over 3 times 12. And then I have u 3 over 2 plus 3, right? Let's simplify that. 2 over 3, that's 1/6. With 3, I have 1 over 18. So here we have u, right? But we need is integral, is the answer for the x. So I have to substitute this back here. So finally I will get 3x4 plus 5 to 3 over 2 plus c. That's how we evaluate integral by using substitution. We do substitution, we pick a good substitution, we find differential, derivatives, we rewrite the original integral in terms of new variable. We evaluate new integral with respect to new variable, and then finally, once we got the answer, we have to use the substitution. We have to substitute it back here to get the final answer for the x. Alright, so I hope that you enjoyed the video and get more confident before test on Friday. If you have any questions or concerns, just let me know. I can arrange online meeting with you. Alright?